Part two. So part two. Problem number 4. When they ask you to find the when they ask you to the sample size of n equals 4 are taken from the normally distributed in 2000 normally distributed in 2011 sales data. What is the shape of the distribution of X? So
I think because it's normally distributed, it's a normal shape. It's not
yeah, but that has to be more with the theorem of the theorem that they give you last class. Do you remember that?
Oh, are you talking about the central limit theorem?
Yeah, the central limit theory. They say that the if the distribution is large enough, so it's going to be normally distributed, right?
Yeah.
Yeah. So the size is 4, right?
Yeah.
And because the size is 4, 4 is a small number, so it's not normally distributed for that reason. Make sense?
Yes. Let me just double check the answer key.
Okay.
It says normal. For number
normal?
Number 4 and number 5, it says normal.
Oh, yeah. The tutor told me that this is not normal distributed because the theorem of that theorem.
Yeah.
I don't know where I put my notes from my class for last class. Yeah, I just lose my. I think I did. I lose my notes for the last class. Anyways, so the key question said no, it's normal, right?
Yeah.
Anyways, well, my tutor said this is not normal, and for me it makes sense actually, because the conditions for the theorem is that it has to be normal enough in order to be normal, right? Because they say that when the distribution is closer to 1, is it's normal, something like that, right?
Yeah.
Let me go to the question, right, lesson 6. So this is why I think it's not normally distributed, because the number of the samples is not enough for this small one. However, unless in question number 5, they say that the size is 40. So because the size is 40, I think it's large enough to be normally distributed.
Yeah, that's what I think too.
Yeah, it makes sense with the tutorial that they send us for that for the parent distribution, something like that, with parenthood something. Do you remember that like the small square that they will just fill in from in the windows?
Oh yeah.
Yeah. So yeah, that was my connection with. Yeah. Oh, I found it. They say, and then remember, say the distribution sample mean is normal when X is normally distributed, or when, thanks to the central limit theorem, or sample size is large. So the distribution means is normal when X is normally distributed, when it's large.
Okay, so does that mean that even though in this particular sample there were only 4, as long as the first one, there was a lot of samples, so it'll be normally distributed?
Yeah. If the number of the samples is large enough, like 2 or 3, like 40 or 10, maybe more than that, so it will be normally distributed. But if not, it's not.
Okay.
Okay. Number 6. Number 6 says a sample size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed x is minor, or is bigger than 40? For that thing, you have to find the z-score first. So C equals, for the new standard deviation, that you have first to find the new standard deviation. So, and the problem is they give you that the sample numbers equals 4. So the new standard deviation equals the old standard deviation, that is 10, right? For the cells. I think the standard deviation equals 10. You're with me or no?
Yeah.
I will share my screen here. Okay. So, do you see my screen though, by the way?
Yeah, I do.
So, okay, so the old standard deviation, or is this in the way that I understand the explanation in the book? So for me, is that old standard deviation equals 10. And because they give you for that sample in the problem equals 4, so you have to find the new standard deviation. So 10 divided for the root square of 4 equals 5, right?
Yes.
So this is the new standard deviation. Now, with your new standard deviation, you have to go to find your z-score. And in that textbook, they say that the z-score equals the observation is larger than 40, right? So you have to put 40 minus 45. Remember that 45 is the mean over the new standard deviation, and that equals -1. So that -1 z-score you have to put in the applet, and the applet, what is the applet? Here. The applet is -1, right?
Yeah.
-1. But what they tell you in the question that they say that what is the probability that the observed is larger than 40? So
less than.
I'm sorry?
Less than 40.
Oh, less than 40?
Yeah.
Okay. Less than 40. Okay, so because they say that it's less than 40, oh, that's right. So yeah, because they say that it's less than 40, you have to shadow this part of the applet, right?
So where would 40 be? Confused now. So why is it on the right side? Like if it's less than 40? Yeah,
less than 40. I think that they mean that over there, like in this part, is 40. So
40 would be 40. Like 4 on the picture graph.
Let's see that. Okay. Let's say that. Okay. So less than 40. So yeah, you have to.
Okay.
So gotcha. The area equals 0.1587, right? So yeah. that area equals the probability. So the probability is 0.1587.
Okay, so I'm glad that you mentioned the new standard deviation? Because I missed that one.
Yeah, the new standard deviation, it will be, you remember, oh, what is that?
Although I have a question because so after you find the new standard deviation, so you do the equation, the 40 minus 45 divided by
5.
10 divided by the square root of 4, which is 5.
Yes.
That equals -1.
Yeah.
So you put that in the applet. So where is it that you need the new standard deviation, or is this equation giving you the new standard deviation?
Because because this is my way that I understand the new with the old standard deviation. Because for the problem, when they give you the mean and the standard deviation, they work with a number of samples, right? But in the problem that the problem is we have to work just with 4 samples. Make sense?
So is it possible that this particular example is going to give us -1, and that'll be the same answer, but is it possible that the old standard deviation equation would be different than the new standard deviation?
I think it's for the number of the I think it's for the number of the samples with, are you like the amount of samples that you are working with, because for the first, in the problem they give you that they're working with, actually they didn't give you with how many are working, but they give you certain details, kind of like the mean and the standard deviation. But now in the problem 6, they say that sample, they tell you that they taking a new sample, so the new sample has to be rearranged. I think this is why we find the new standard deviation, or the standard deviation, the sample, just the four samples. Make sense?
Okay.
This is my way to understand, though, because I was trying doing my best to understand the book, but I don't know, until lesson 5, I think, lesson 4, I think I got it, the book, but now 5, 6, 7 is kind of hard for me to understand.
I completely understand. Okay, so number 7 then, let me see how I do on this one. So a sample size of n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed X is greater than 35 and less than 55? So you take greater than 35. So you would take 35 minus 45, which is the mean. And then you divide that by 10 divided by the square root of 4, which is 5, and you would get -2.
Yeah.
And then 55, less than 55, so you do 55 minus 45, and then you divide that essentially by 5, and that equals 2. So you would put the -2 and the 2 in the applet. And so that probability looks like 0.9545.
So you put just -2 and 2, right?
Yes.
Yeah, okay. So, but what was the question? The question was that X has to be great. I'm sorry.
Yeah, sorry, greater than 35 and less than 55.
So, doesn't mean that. Okay, wait a second, really quick, okay? Give me 2 seconds. Okay, there we go. Okay, I'm back. Sorry, because my husband came and take some. Okay.
I want to get out of there. Just kidding.
Okay. So the question for the problem is, they say the probability that's observed X is greater than 55 and less than 35 and greater than 35 and less than 55, right?
Right.
But for that reason, you find the C-score for 35 and the C-score for 55, right?
Right.
Okay. So because they give you these two parameters, so the area that we are looking for is the middle of these two, right?
Correct.
So the area is 0.9545.
Yes.
Okay, perfect. So this is the answer. This is the probability for greater than less than that one.
This is making me feel a little better.
Yeah. This is the part of the question that I understand. So the other one I don't understand. This is why I'm just going to talk with a tutor. I'm going to make an appointment because I really need help. It's just feel that lessons are coming, and getting like a huge snowball that's getting bigger and bigger and bigger with all my doubts. So.
Yeah.
Okay.
I understand.
So question number 8, right?
Mm-hmm.
Okay. For question number 8, you have to do the same, right?
Right.
Okay. So okay. You notice something on my ear? The size number of the sample now is 25.
Oh yes, I did.
So that means that we have to find a new standard deviation, right?
Yes. They need to stop, like, trickiness.
Yeah. I just want to make sure that you notice that because it would be worse if you just go into the whole thing because you have to do two C-scores, and then you find out that you just forget to find the new standard deviation of that.
Yeah. And I missed that, so let me work on this for a minute. So would it be 41 minus 45 divided by 10 divided by the square root of 25, or am I?
Yes.
So can you remind me how to find the new standard deviation again?
The new standard deviation is the old standard deviation over the a square root of n.
So it'd be 10 divided by a square root of 25, right?
Yeah,
Okay.
equals 2, right?
Yes.
Okay. So now that you find the C-score for each of those.
Well, because it's the -2 and +2 for the other equation, the 49 minus 45 equation, would it be the same number, the 0.9545?
So what?
Sorry. So what would be the probability that is greater than 41 and less than 49? Because the z-score is -2 for the first one and it's +2 for the second one, would it be the same probability? I mean, the same answer.
Yeah. So you make the C-score is 41 minus 45 divided into 2. Yeah. There's something like that you found it.
I did. Hang on a second. Yeah, so 41 minus 45 divided by 2 is -2. And then 49 minus 45 is 4 divided by 2 is 2.
Okay, I think we found a different thing. Oh, you're working for 45 and 55, right? 35 and 55, right?
41 and 49. Greater than 41 and less than 49.
Okay, so it will be 41 minus 45 divided into, yeah, no, equals no 2. Yeah, 41 minus 45, 41 minus 45 equals -4 divided by 2 equals -2. Yeah, you're right. That would be the same, huh?
Yeah, I think so. Let me double check the answer too.
Yeah. But now they ask me.
Yes, it says. Okay, so it says, so for the answer for number 8, z parentheses x less than 41 equals -2, and then z parentheses x less than 49 equals 2. So the probability about 0.95. This is using 68, 95, and 99.7 rules, or 0.9545.
Yeah, it will be the same.
Okay. Excellent.
Yeah, intense, huh? Okay. Oh my god.
Not for me.
Oh, yes, intense. I want to finish the class. Oh, okay. Anyways. Okay. So for number 8. So number 8 will be 50 50 minus 45 divided by 2, right?
Yeah.
It was 2.5, right?
Yes.
2.5. 2.5. Híjole. What? 2.5. Okay. So where you get in the probability for 9? What is the probability of that? Is it greater than 50? I got 0.0062.
Yes.
Yeah, I got that. Yeah, that's right.
Okay.
Okay. Question number 10, 11, and 12. They're from the theory. And
So on this one, I just want to make sure I'm getting it right. So because the sample sizes that were taken are right skewed. Oh, brother. Okay, sorry. So because the parent whatever, is right skewed, that means that both 10 and 11 would be right skewed. Is that correct? Because
number 10 is right skewed because the sample is less than that. This is a small group, a small sample, small like amount of samples, you know. So you remember that when you are doing the parenting thing, when you just add 5 or when you just add like 2, do you remember that when they're falling off, they try to keep their same shape? You remember that? So this is why number 10 is right skewed. So the sample, because the number of samples is a small one, so it will be the same one or that is given in the problem before. Because it's told you that the distribution is right skewed. So the sample is small, so it has to be the same, small skewed too, it's right skewed too.
So what about number 11 with a larger sample size?
With the larger sample size, it's approximately to the normal. Because when you remember that when you start like changing numbers to this Java thing that it was filling blocks for the graph, when you put 100 or 1,000, all of the distribution try to be normal, right?
Okay.
Try to be normal distribute, and this is true for the theorem, for the limit. What's the name? Central limit theorem. Theorem.
Okay.
And this is right.
Okay. So basically that answers number 12. The theorem that justifies your answer. You just answered that beautifully. Okay.
Okay.
So
thank you. Okay. I have news for you. Number 13, I don't have idea how to do it.
Okay. Yeah, this one I don't know either exactly. So the reason, okay, so can you compute this probability using the normal probability applet with the information you have, and why?
Wow.
My guess was no, because the sample size is not large, therefore the essential limit theorem does not apply. But that was a guess. I don't really know.
I don't have idea for number 13. The solution key, they say that this not the distribution is not normal, and the normal probability applet is only for normal distribution. So that sounds more like a theory question, but I
The applet is particular about what it's used for.
don't know. Yeah. Yeah,
Okay, so only normal.
that's true. If you put number higher than 1, it's not going to accept you.
Okay.
I think number 14 is like the same of our other problems. They say that if the sample now is 36, so will be what is the standard deviation now is 12, sorry. So 12 divided by okay, 12 divided by 6, this is it's 2, right? So the new standard deviation is 2. New standard deviation is 2, is 2, is 2, is 2. So then you have the probability, so 36.5. What is the mean for the poly? Minus 40. Oh my gosh, my calculator is dying. Minus 40 equals minus 3.5 divided by 2 equals minus 1.75 is the C score, right?
But where did you get 40 from?
40. Oh, it's a good question. Oh, 40, because in the problem, when they say per computing solved an average of mu equals 40, the mean is 40.
Oh, brother, where is that at? It's at the very top, right? Oh, okay.
Yeah. It's right after problem.
Doing it, I was keeping the 45.
75. It was greater than 36.5. So it is.
So is that 0.0401? Is that what you got?
Mm-hmm. Wait, what is that?
The probability that X is greater than 36.5.
Okay, yeah, that sounds a lot makes sense. But I was checking the key sheet, and I figured out that the minus 0.7050, yeah, is when you subtract. Actually, you subtract 36.5 minus 40, right?
Yes.
Yeah, and then divide under 2, right? And you give the answer is minus 75.5. So it means that this, which are my screen? So that's mean that here in this place is going to be located the 36.5 or something like that. Yeah, the 36.5.
Oh, okay.
So this is the result. So because they ask you for is greater than that, so it has to be at the right side, right? Where is 1, 2, 3, and greater than that. So you have to shadow the central part and the Left side for me, I think, is the right side for you. My gosh, it's so hard. So yeah.
Okay, thank you. Glad you pointed that out.
You're welcome. Okay, so okay. The next one is number 50, right?
Yes.
So in the last one, I cannot believe it. Oh my gosh, I'm going to cry. Okay. So yeah, because I just want to finish this chapter until tomorrow. They're going to have an appointment with a tutor. They have more clear things. Okay. So they say that the size is 36, so the new standard deviation will be the same. It's 2. But now they ask you to find between 37.5 and 42.5, right? So
Right.
is common. Do you remember the example when you have to find like for 35 and 55? You have to do the same thing for this problem. So now you're going to have 37.5 minus 40 divided on 2 equals 17.5. So the C 17.5 shillings. Okay, make sure that I have the right numbers because sometimes I just get excited and it's not the right answer. Okay, so 37.5 minus 40 over 2. And the other one is 42.5 minus 40 over 2. So 42.5 minus 40 divided by 2 is 1.5.
That 1.25?
Uh-huh.
Okay.
And then that's 37.5 minus 40. It's minus 2.5 divided by 2. Minus 1.25, right?
Yes.
Okay. So minus, okay. No. Minus 1.25. Okay. Because they tell you that you have to find the probability that the observed x between 37 and 35. So you just have to shadow the central part, right?
Yes.
So the answer will be, the probability will be 0.7887. That's right. Yeah. Well, yeah. Decimals, you know. They find 0.788888. 887. Anyways, the homework is done. Yay.
No offense, but I will be so glad when this class is over.
Me too. I just repeat the same myself. Okay, because I'm recording this stuff, I will just be soft with the comments. Anyways, okay. Thank you very much, Elmira. I will try to do the quiz later because now my head has to rest.
I need a break as well. Okay.
Okay.
Thank you.
Well, I will text you the answers, okay? And you as well, if you got it first than I. Just send me the answer so I can compare with my answers to make sure that I get the right ones. Okay?
Yeah.
Okay. Thank you, Meyer. Have a wonderful day. See you next week.
You too.
Bye.